Welcome back as we next discuss the refrigeration cycle. To begin, let us represent a system as being made up of 4 essential components, which are all connected via tubing in an endless loop through which refrigerant is caused to flow. The 4 main components of any system are a compressor, a condenser, an expansion device, and an evaporator. Let us begin to identify these components on our model unit. Here we have the compressor. This particular compressor is known as an accessible hermetic type. The next component is the condenser. A dominant feature of our condenser is the large cooling fan attached to it. This is where our unit derives its classification as being air-cooled. The third component is the expansion device. This particular type is known as a thermostatic expansion valve, recognizable by a thermostatic sensing bulb connected by a capillary tube to the diaphragm on the valve body. The final major component, featured on our model, is the evaporator. This evaporator employs air draft fans to assist with the air circulation over the coils of the evaporator and in the cooling space. A feature of evaporators and condensers is that they are both made of metals, such as copper and aluminium, which possess good thermal conductivity characteristics. Let us now describe the operation of each component. The first device that we identified was the compressor. Vapor is drawn into the compressor and compressed. This has a dual effect. It generates the energy required to force refrigerant around the system, and it also raises the temperature of the refrigerant vapor before it is discharged into the high-pressure side of the system. From here, hot vapor, that is under pressure, moves on to the next device, the condenser. The condenser is, in essence, a coil of copper tubing through which the hot vapor is caused to flow. Heat flows out of the vapor by conduction into the tubing. From the tubing, this heat is conducted into aluminium cooling fins which are attached to the tubing. A fan mounted on the condenser forces an airflow over the fins and carries away the heat into the atmosphere. The vapor in the tubing cools to a temperature below its saturation point and thereby condenses. Now in a liquid state, the refrigerant continues under high pressure along the liquid line to the expansion device. The main function of the expansion valve is to control the amount of flow, or mass of refrigerant, entering the evaporator. It does this in such a way that the amount of liquid being fed to the evaporator corresponds with the amount of cooling work that has to be done. As fluid passes through the expansion valve, it has to flow through a metering orifice. This results in a spraying effect and a rapid loss of pressure in the refrigerant as it enters the final component, the evaporator. The evaporator, like a condenser, is a coil of copper tubing to which aluminium fins are attached. However, unlike the condenser, there is a low pressure created inside an evaporator caused by the suction action of the compressor. Lowering of pressure means that the liquid's saturation temperature drops and rapid boiling, which is a change of state into vapor, starts to occur. During this change of state, or evaporation process, heat is absorbed by the refrigerant out of the tubing. The coil becomes cold and in turn absorbs the heat contained in the surrounding air. This heat is then carried off by the vapor flow. By the time that the refrigerant arrives at the end of the evaporator coil, it will have completely evaporated. Vapor is now returned to the suction side of the compressor. This cycle of refrigerant flow repeats for as long as the compressor is running. From our explanation, you can appreciate that a system depends upon two key factors, namely, to maintain a low pressure in the evaporator and to maintain a high pressure in the condenser. During maintenance, the pressures are monitored carefully, making a definite separation between the low side and the high side of a system. After the break, we're going to look at other items which exist in typical mechanical systems.